Alright, number 7. So a sequence is defined by the following. So what it says here is that the first term u1 equals 3, and then we got some sort of recurrence where the next term equals the previous term minus 5. So that's what n plus 1 means. It just means the next term after n. So if it was u2 here, it must be u1 there, u3, and then u2 there, and so on. Okay, in the question, it wants us to find the values of the next 3 terms, u2, u3, and u4. Alright, let's do it. So to find u2, we're just going to plug in u1 back. And since we know that u1 equals 3, it's going to be 3 minus 5. And that's it. That's just going to be minus 2. So that's our u2 value. And then for the next one, u3, we plug in u2 back in. So minus 2, and then follow the sequence, minus 5. That's going to give us minus 7. And as you can see, doing the same for u4, you plug in u3 back in. So it'll be minus 7, and then subtract 5 will give us minus 12. That's it, guys. That's A done. Now for part B, it uses a slightly different trick here. To find the value u100, well, let's go back to some of the formulas we know. We know that for an arithmetic series, let's say un, it's always going to be the first term a plus n minus 1 times a common difference d. Okay, so this is a standard formula. We want to find u100. So this is going to be the 100th term equals the first term. And now what you should realize from this, like, what is the first term in this case? It's going to be the sequence from u1. So if we imagine what we just found, so we found the u1 value, and then u2, u3, and then finally u4. We can see that the first term is 3, and then there seems to be a common difference of minus 5, because it's going down by minus 5. So in this case, we say a is 3, d is minus 5. Plug this back in, so you can get 3 plus, and then n is 100. 100 take away 1 is 99 times minus 5. And then putting this in your calculator, you should get a value of minus 492. That's it. That's B done. Now the last one is part C. So they want us to find the sum. So that notation means sum from the first term all the way to 100. So essentially, you're trying to find the value of u1 plus u2 plus ... all the way up to u100. Now to do this, you could just use the summation formula, because in the arithmetic series we know about the SN rule, where SN equals n over 2 times a plus n minus 1 times your common difference d. Now plug in all the values we know a is 3, d is minus 5. In this case, n is 100, so we should get 100 over 2. 2a is 6 plus 99 times minus 5. Basically plug this all in and you should get a final result of in your calculator minus 24,450. And that's it, guys. That's 7 done. Okay, number 8. So the quadratic equation, which is this bit here, where k is a constant, has no real roots. Okay, when something has no real roots, this implies that the discriminant b squared minus 4ac must be negative. Okay, this literally tells us that when you plot a u-shaped graph, it does not touch the x-axis. If it did touch the x-axis, then you would have a real root. If it goes through 2 points, then you have 2 real roots. Okay, so let's keep going. A, show that k satisfies this inequality. Alright then, so what you literally have to do, so we start from the no real roots part, and we're just going to substitute the value of a, b, and c into this equation here. The values of a, b, c correspond to this part, the b part here, and the constant c. So a is going to be k minus 4, b will be minus 4, and c is going to be k minus 2. So let's plug it in then, yeah? So the b squared is going to be minus 4 squared, which is just 16, minus 4 times the a part, which is k minus 4, and c is going to be k minus 2. And because it has no roots, it's going to be negative. Right, so what we're going to do now is just expand this to the best we can. So let's do this here. So we're going to have 16 minus 4. So let's go expand the quadratic bit here. So we're going to have k times k is k squared. K times minus 2 is minus 2k, but then minus 4k combined makes it minus 6k. Lastly, minus 4 times minus 2 is plus a. And that's less than 0. Alright, so the next bit now, let's expand the bracket further. We're going to have 16 minus 4k squared plus 24k. And then this one, minus 4 times 8 is minus 32. Now, let's just tidy this up. So notice how the sign is greater. And you can see k squared is positive. So they probably moved everything to the right side, yeah? Let's do that right now, yeah? But before that, actually, let's tidy up first. So you got 16 take away 32, which is minus 16. And then minus 4k squared plus 24k less than 0. So moving it to the right hand side, we're going to have 0 less than, and put this in order, 4k squared minus 24k plus 16. And just for the sake of it, let's just put the greater than 0 on the other side, yeah? So it'll be greater than 0. Now to see what they got, well, they actually fully simplified it. It looks to me like they divided the whole expression by 4. So let's divide it by 4, yeah? Doing so, we're going to therefore get k squared minus 6k plus 4. And we're done. So that's A done, guys. Now for part B, we have to find the exact range of possible values of k. So this is literally telling us to solve this equation now and find out what k could be. So because it's a quadratic, let's use a quadratic formula and solve this, yeah? So doing so, we can say, we can just pretend this equation equals 0 as well. So let's use a quadratic formula. We can say that k equals minus b plus minus the square root of b squared minus 4ac over, 2a. Now, in this case, our a value is going to be the coefficient here, which is 1 in front of k squared. B is going to be minus 6, which is this bit. And c is going to be plus 4. Okay, so when you substitute all this in the calculator, guys, by the way, you're going to get something like this. And because I already done it, I actually got 3 plus minus root 5. Now, to be sure, you know, just do the plus, for example, and it should come out as your calculator as 3 plus root 5. If you put the negative sign, you're going to get 3 minus root 5. So you can collectively write this. Now, since we got this is known as the critical value, yeah? So what that means is that this is literally, we're going to find out whether k is going to be bigger than one of them or less than other. But to be absolutely clear, let's plot this on a graph, yeah? So we always plot a graph. Let's call this side k, and then whatever this is, let's just call it a function of k, yeah? We're going to have the roots, 3 plus root 5, 3 minus root 5. Let's just say 3 minus root 5 is here and plus root 5 is there. So it'll be a nice U shape. Now, because the graph, what do we know about the expression? Because we know that the equation is greater than 0, this means that for the equation to be greater than 0, it has to be above the y-axis. So it has to be from here. The line goes above the y-axis at these points. And just remember, this is 3 plus root 5, and this is 3 minus root 5. So therefore, we could say that the possible ranges of values of k is going to be greater than this quantity. So k would be greater than 3 plus root 5, or k is going to be on this side, less than 3 minus root 5. So k is less than 3 minus root 5. And that's it, guys. This would be number 8 done. Okay, number 9. So a cyclist aims to travel a total of 12 kilometers over a number of days. We know that he cycles 12 kilometers on the first day. He then increases the distance that he cycles each day by 6% of the distance cycled on the previous day, until he gets to 1200 kilometers. Now, so what this is trying to say is that we have a geometric sequence where on the first day, which is A, he travels 12 kilometers, and then that the common ratio is that it increases by 6%. So it's not going to be 6%, it's an increase, so it'll be 1.06. If it was a decrease, it would be 1 minus 6%, which would have been 0.94. So in this case, this is what we have. And he's going to keep on doing this until he gets to a final distance of 1200. Okay, cool. Now A, show that on day 8, he cycles approximately 18 kilometers. Okay, so before we do this, let's look at some general formulas, yeah? For any given day, we need to know that the general formula, which is UN, is going to be A, the first day, times the common ratio to the power of n minus 1. Alright, so this is the key thing. Now we're trying to find the 8th day here. So it's going to be U8. That's going to be equal to A, which is 12, times the common ratio, which is 1.06, to the power of n minus 1. So 8 take away 1, which is 7. And when you calculate this, you should get something like 18.04. And as you can see, that's approximately 18 kilometers. Okay, great. So that's 3 marks for that. Now, next one. he reaches his total of 1200 kilometers. So this is total, yeah? So this will be the sum on day n, where n is a positive integer. Find the value of this n, alright? So to do it, let's record the other formula, which is the sum, the geometric sum. And this is equivalent to a times 1 minus the common ratio to the power of n over 1 minus the common ratio. So this formula, I think it's best you just memorize these formulas because you're going to use them all the time. Now, all you want to do is literally just plug in all the values. And oh yeah, the total has to equal 1200. So that's another key thing. So literally, you're going to end up solving an equation that looks like that. Now, updating your values, yeah? So we've got a, which is 12, and r is 1.06. We're going to have 12 times 1 minus 1.06 to the power of n over 1 minus r, which is minus 0.06. All of it equal to 1200. Now at this stage, you just want to go ahead and solve for n. So what we could do, we can just put in our calculator right now, 12 over minus 0.06, and then using the answer, put 1200 divided by that. And you should be left with something like 1 minus 1.06 power n equals to minus 6 on the right side. Now just rearranging this, so I'm going to add 6 across and plus this term to the right. We're going to get 7 equals 1.06 to the power n. Okay, so now looks all good so far. But the next thing is to somehow work out that value n. So what I would personally recommend, just take logs, yeah? If you take logs, it will drop the n down to the ground. So let's do it. We're going to have now log of 7 equals the log of 1.06 to the power n. And from here, n becomes a term in front. So it'll be n times log 1.06 equal to log 7. And finally, just divide log 1.06 across. So you're going to have log 7 over log 1.06, and it should equal n. And in your calculator, you're going to get approximately, what is it, 33.395 ... which is, and what it says here, you want to find a positive integer. Because this counts as days, this is like saying 33.39 days. And you're basically on the next day, so this is more or less the 34th day, but early on. So you're on the 34th day. And that's it, so n is 34. Okay, part C. So the cyclist stops when he reaches 1200 kilometers. Okay, and we know that that's exactly at time n. Find the distance that he cycles on day n, giving your answer to the nearest kilometers. Ooh, interesting. So what do we know? So we know that exactly at this point in time, so on the 33.395th day, he traveled exactly 1200 kilometers. So let's just ignore this 34th day for a moment, yeah? Let's work with this decimal. If we make a little timeline, let's say from here all the way to the end, and just label this 1200 kilometers, we can see that for the first 33 days, which we were able to compute, by the way, plus this extra little decimal date, 0.395, this will give us a total of 1200 kilometers. Okay, so now we just need to compute S33. So what does that give us? Well, using the general sum formula, it's going to be a times 1 minus r to the 33 over 1 minus r. And we know what a and r is. A again was 12, r was 1.06. If you plug it all in here, you should get a distance of 1168 kilometers. Yeah, so that's how much he traveled in the first 33 days. So technically, if he stopped at 1200 kilometers at some point in the 34th day, like early on in the day, that means for the remaining distance, if you subtract 1200 from S33 from this result, we should get that small distance of 32 kilometers. And that's it, guys. That's literally how much he traveled on day 34.